Hello, my name is Jeff Kinehart, and today we are going to have an introductory talk on soils, kind of an overview of this complex topic. There are many different definitions of soils depending on where one went to get them. This particular definition comes from the Soil Taxonomy textbook and states soil is a natural body comprised of solids that would include minerals and organic matter, as well as liquids and gases that occur on the land surface, occupy space, and is characterized by one or both having either horizons or layers that are distinguishable from initial material as the result of additions, losses, transfers, and transformations of energy and matter, and also has the ability to support rooted plants in a natural environment. The soil profile varies in depth by geographic region and forces of both nature and man. Erosion, sediment deposition, and tillage are some of the factors that can impact the soil profile. A typical soil profile is shown in the diagram above, and depending on where you're at in the state, this entire soil profile could occur in just a few inches, or it may be 5 or more feet deep depending on where you're at. In southern Illinois, the soil profile tends to be quite shallow. In central Illinois, the soil profile tends to be quite deep. The mineral components contained within soil consist of various sized particles. In some cases, very large particles called gravel may be present. Commonly, sand, silt, and clay, all three, are also present. These are differentiated from one another on the basis of size, as is seen in this diagram. Sand being larger sized particles, silt being medium sized particles, and clay being very, very fine sized particles. The percentage of each, sand, silt, and clay, is what goes on to determine soil texture. This is a soil texture triangle. Soil texture is determined by triangulating the percent sand, silt, and clay. More or less equal parts of all three give rise to a soil that is referred to as a loam, which is commonly touted as the best soil for many of the plant species that occur on Earth. Another property of soils is cation exchange capacity. This refers to the negative sites that occur on the outer surface of the soil colloid and also organic matter. For field production, high CEC or cation exchange capacity is considered desirable because these sites temporarily hold cations, that is, positively charged ions. Many, such as calcium, magnesium, potassium, and iron, are required for plant growth. The exchange sites help to keep positively charged plant nutrients from being washed away or leached into deeper layers of the soil profile where there are fewer roots available for nutrient uptake. There are 16 commonly recognized nutrients essential for plant growth. Many believe that there are a few additional required elements for normal plant growth, but because of the way essential has been defined, it is likely that this list of 16 will remain as the only essential elements. Of the elements in this list, we do not worry about supplying carbon, hydrogen, and oxygen. The other 13 are all things that growers may be concerned about being present in sufficient quantities. The major elements are required in the highest volumes, followed by secondary nutrients. Micronutrients are typically only required in small, or sometimes referred to as trace, amounts, but even though they are not required in large volumes, there are several situations in which they can be the limiting factor to plant growth and or crop yield. Plants most commonly uptake nutrients from the soil solution. Plant nutrients may already be dissolved in the soil solution, or they may become dissolved in the soil solution after being displaced from a cation exchange site by another cation. For example, hydrogen, sodium, or aluminum may wind up binding with the cation exchange site, releasing magnesium, potassium, calcium, or some other necessary plant nutrient. Plant root uptakes nutrients from the soil solution as the most common form of assimilation. The amount or number of cation exchange sites is referred to as the soil's cation exchange capacity and is commonly reported on soil tests. Sand has very few exchange sites, while silt has more and clay has even more. However, as this slide illustrates, soil humus, commonly derived from organic matter, has the greatest potential to increase soil cation exchange capacity. Here's a slide. It's just a different way of showing some of the potential CEC values for various types of soil. This map shows a general expectation of the cation exchange capacity of soils throughout the state of Illinois. Before deciding to purchase or rent a piece of property, it might be a good idea to learn about the site's soils. The soil surveys are now online and can be easily accessed through this website, websoilsurvey.nrcs.usda.gov. One of the methods of navigation allows you to simply enter the physical address of the property that you are interested in learning more about the soil. Once you've found the general section that you're interested in, you can then refine the area that you're really wanting to search. Once you have selected your specific location that you are interested in, then soil types and subsequent characteristics of those soil types can be further explored on this website. Detailed information about the various soil series found on the farm can be looked at, as you see right here. In this particular case, we are looking at information about the soil series found on this particular farm in DeKalb County. Again, we have a great interest in soil types in the area where you're going to be farming, because soil type has a direct impact on so many aspects of agronomic and horticultural production. Because of that, it is important to study the soil maps of any area one is interested in renting or purchasing or utilizing to grow any kind of commercial crop. Some of the factors directly influenced by soil type could be plant selection. For example, if the soil type is such that it is poorly drained and has a pH of 6.5 or higher, then we're simply not going to be able to utilize that site to successfully raise blueberries. There are other examples where plant selection could be influenced by soil type. Additionally, how the irrigation will be managed will be directly impacted by soil type, as will drainage. Fertilizer recommendations and yield potential vary from soil type to soil type, and in some cases, some herbicides actually even wind up changing the rate required based on soil type. Not all herbicides have this condition, but some do. While soil type is determined by geographic location, soil structure is also important and can be improved or damaged based on horticultural practices such as tilling, cropping, and the use of cover crops. Soil structure is defined by the way individual particles of sand, silt, and clay are assembled. Single particles, when assembled, appear as larger particles. These are referred to as soil aggregates. High residue and cover crops can contribute organic matter to the soil, which in exchange will result in better soil structure or better aggregation of the individual soil particles, which results typically in the soil being able to do a better job of growing plant material. Soil structure has a direct impact on bulk density. Bulk density refers to the weight of soil per unit volume. Soils with good soil structure and good soil health tend to have lower bulk densities and provide improved plant growth. Practices that destroy good soil structure tend to increase bulk density and reduce plant growth and yields. Examples of practices that could damage soil structure would include things like excessive tillage, high traffic, or field preparation when soil conditions are really too wet. This is a picture of a penetrometer, and it shows the correlation or relationship between soil penetrometer readings and soil bulk density. So with this device you can go along and get a feel for areas that may have become compacted in your field. Compaction zones often develop as the result of repeated tillage at the same depth. If we encounter a problem with compaction, there are ways that we can repair that, and we should also work to prevent it. One of the ways to prevent it is by not doing all of your tillage at the same level each time you go out and till. So in other words, we wouldn't just go out and utilize a rototiller every single time we needed to perform tillage on a given piece of ground. Practices such as double digging or subsoiling are examples that can help alleviate compaction problems that have resulted from any number of factors, but including continuous tillage at the same depth. Another example that we see is core-aeration of lawns or landscapes. It's another example of a method of repairing compaction problems. In addition to mechanical methods involving more tillage, like double digging and subsoiling, some cover crops may also be useful in repairing compaction problems. Some commonly utilized examples of this would include things like tillage radish and annual ryegrass, both of which have root systems that may help to fracture the fragipan and result in improved drainage, improved growth because of the alleviation of problems associated with compaction. Here is the chart on the right, just kind of gives you some ideas of what sorts of compaction forces are exerted by different types of activities in the farm, and you can see that walking on your heels induces a lot of pressure as opposed to flat-footed, which doesn't have too much psi of pressure. But you can see that one of the chief offenders would be things like driving pickup trucks out into the field where you're working. So one of the things we might like to do is minimize rototilling and vary your depth of tillage so that we don't continuously work the ground at the same depth. Try to minimize walking on soil. Things like raised beds help guide traffic into walk alleys as opposed to walking on ground where we're going to actually be raising our crop proper. And don't drive trucks or other vehicles across the soil. If you're raising a crop where we're going to have a vehicle out there as part of the harvesting process, which is fairly common, then it would probably be best to lay the field out so that we have 6 or 8 or 10 rows of crop that we're raising, and then a dry valley which is left bare so that, or planted to a cover crop, and we drive only on the drive aisles and we don't actually drive out in the area where the crop is really being raised in the field. And lastly, we'd like to spend a little bit of time talking about interpreting soil test results. And when you send your soil sample off, at some point you're going to receive an analysis report back from whatever lab that you have utilized. And what I'm wanting to make sure that you know is that nutrient levels are reported by some labs, such as the one seen in this picture, where the nutrients are reported in terms of parts per million. Other labs, like this, give nutrient levels in pound per acre. It is critical you are certain which of the two methods you are looking at when you go to interpret these results. You must determine whether or not the soil test is giving you results in terms of pounds per acre or parts per million. And the reason that that's so important is that there is a factor of 2x associated with that. Pounds per acre is equal to parts per million times 2. And the basic reason behind this is that an acre furrow slice, that is a slice of ground across 43,560 square feet, that is 6.5 inches deep, weighs approximately 2 million pounds. And that's how we wind up with pounds per acre being equal to parts per million times 2. Once we have looked at our soil test results and figured out what numbers we are looking at, and we're sure if it's part per million or pound per acre, then we can go on and do just a little bit here at the end about some of the recommendations that we would try to follow based on soil test results. This is a scale showing you pH, which ranges from 0 to 14, 0 being acidic, 14 being alkaline, and 7 being neutral. For blueberries, acidic soil, that is less than 5.8, is required for sustained and good plant growth. And if blueberries are planted into soils that have neutral pH, they will inevitably die within 1 or 2 years. However, blueberries and a few others are exceptions. For most crops, soil pHs of 6.5 to 7 are most desirable. The impact of pH on crop yield has been widely demonstrated on numerous crops. And you can see here that as we raise the pH from 4.5 to 7, we have a tremendous increase in yield of wheat in this particular example, although other crops would typically show a similar response. Why is this the case? Well, by adjusting pH, we maximize the availability of many of the plant nutrients. Although the total volume of plant nutrients that's in the soil really doesn't change, but by having it at the correct soil pH, we have those plant elements in a chemical form that is available for uptake and utilization by plants. This leads to the statement that lime is the cheapest fertilizer one can buy. When you lime a crop or lime a field, you are not only applying calcium and magnesium to essential plant elements, but at the same time you are also shifting the pH to increase the plant available levels of many of the other nutrients, even though you're not making additional fertilizer applications. So by taking a pH, if we just look at this example or this chart right here, if we look at, for example, the case of molybdenum. Molybdenum at a pH of 5.0 is not very much of it is in a form that is available for plant uptake and use. When we lime the field and raise the pH to 6.5, you can see that a lot more of the molybdenum is now available for plant uptake and utilization. So even though we haven't added additional amounts of that element, we have increased the amount of it that is available for plant use because we have changed the pH in the environment such that more of it is capable of being utilized by the plant. If you decide that you're going to need to lime a field, you need to consult the Illinois Agronomy Handbook, and limestone recommendations can be found, and a lot of detailed information about how to make liming applications can be found in that particular publication. Again, this is some recommendations from the Illinois Agronomy Handbook, and in it contains much more detailed information about how to make decisions on the amount, quantity, and quality of limestone that you would need to utilize to change your soil's pH. Fertilizer recommendations can be found from numerous sources, such as this particular publication, which is the University of Kentucky's Vegetable Production Guide for Commercial Growers. I do caution that there is a lot of fertility information, particularly for vegetables, that has been written in Florida. And Florida has a lot of muck-type soils rather than being mineral-based. They're pretty much organic soils. And those recommendations really have no bearing for use in the state of Illinois. And in fact, if we follow them, we can actually wind up in a fair amount of trouble. So although you can get your recommendations from a lot of different sources, be careful that you are getting recommendations that are associated with mineral-based soils. Okay, we've got our soil test results back, and now we're going to look at that again and make sure we know whether or not we're in pounds per acre. If we're not, we want to take the soil test results, if they were given in part per million, and convert them to pounds per acre. Once we have our soil test results in pounds per acre, we can now utilize this chart. You locate where your soil test results fall and apply the recommended amounts of phosphorus and potassium that would be required. Additional information on the amount of nitrogen is also provided in this particular publication. And you can see they go on and talk about, depending on what the that we were going to have raised previous to this, we might shift the amount of nitrogen that is required. For some crops, like tomatoes that we are using in this example, fertility is not only provided by pre-plant application, but also subsequent applications of fertilizer are applied through the irrigation system in a process known as fertigation. And so if you'll read this, it'll talk about we're going to put on part of our nitrogen that is required up front, and then we are going to make weekly applications of additional amounts of nitrogen throughout the vast majority of the growing season. This is a different fertigation schedule, still from the same publication, where we're looking at what we would do for a tomato crop if the grower feels that they are going to need additional amounts of potassium to avoid yellow shoulder disorder, a common problem throughout the Midwest. There are some things that are a little bit different when we talk about soils, fertility, fertilizer management in specialty crops compared to corn, soybean, and wheat production in the state of Illinois. It is much more common to see market gardens rather than commercial row crops where there has not been routine monitoring of soil nutrient levels by soil test, and instead by simply making yearly fertilizer applications. This can lead to excessive phosphorus levels and also development of problems with base saturation, that is to say that nutrients can become out of balance one with another. Foliar feeding is also occasionally practiced on specialty crops, and it is a useful tool, particularly to address some specific problems such as calcium applications to address bitter pit of apple or blossom end rot of tomato. Both of those are abiotic diseases that are caused by fertility issues. But normally foliar feeding will be kind of reserved for treating some specific problems, and it is not normally used as a tool for providing the entire season's requirements for plant nutritional needs. Because of the crop value and the diversity of species cultivated, specialty crops differ from row crops with regards to fertilizer in several ways. The high crop value associated with most specialty crops allows for use of some fertilizer materials that would be cost prohibitive in the row crop arena. Additionally, fertigation is often used so that we can make weekly nutrient applications throughout the majority of the growing season rather than just a single pre-plant application or a single pre-plant application in conjunction with a single side dressing event. In addition to soil tests, other testing procedures are occasionally used for specialty crops. Obviously, visual inspection is always important, but beyond that, we may also perform tissue test and petiole sap analysis if we have some specific needs that we are trying to address for specific crops. And based on the results of the petiole sap analysis or the tissue analysis, that is a useful tool in conjunction with our soil test to make adjustments in our overall fertility program. Well, that's kind of an overview of soils, and so again, this is Jeff Kindhart with Not NPR and Only Some Things Considered. Until next time, have a good day. Reach, Mike or myself or Nathan Johanning, feel free to contact any of us with your vegetable questions, and we will be happy to try to answer them in greater detail.